Hello everyone, my name is Adriana Rose and I'll be presenting low-stress coding for high-impact teaching tools. It's going to go pretty quickly, so I won't be able to cover every single piece of code that I mention, but the notebooks will be available later, so you can take a look at that on your own time. So let's go ahead and get started. What I'm going to talk about is I'm going to do a couple one-liners for you, some code snippets for everyone. I'm going to be focusing on secondary education, but I'll also show some elementary school applications as well as higher ed applications. Creating dynamic content, and then really my focus is getting students coding in the classroom, and then I'll show some administrative code snippets that I use for my workshops and students. So the very first thing, and I think everyone can agree, is that the Wolfram language is anything and everything that you would want to create tools and to encourage computational thinking in your classroom. With the Wolfram language, you can create tools for your students to use, and the Wolfram Demonstrations Project is an excellent and amazing resource for you to take a look at what can be created in the Wolfram language. You can also create interactive and dynamic courseware. I've just got a quick little snippet here of what we have going on in our relationship with Pearson, that they have all sorts of interactive figures in the Briggs-Cochrane calculus book, and you can see from this page really nice and smooth interactive features that really enhance the courseware for students. And then, like I said, the ultimate goal is to really get your students coding in class, and I'll show some examples a little bit later. Okay, so code snippets for everyone. I'm probably going to pass over the elementary school examples just because you could take a look at it a little bit later. But I did want to pause on some secondary and higher education examples here. The Wolfram language over the past 25, 30 years has really grown to diversify beyond STEM. And it's a fantastic tool and programming language for STEM, but we can broaden our scope and introduce it into a wide range of subject areas. So here I've got just a one-line piece of code. I'm looking at Colorado given the country, or given the geo range of countries. So here you can see that it's highlighted the polygon of Colorado inside the United States. Again, not a lot of code, a very powerful impact. Grammar, this is something that we just saw at the technology conference with the text structure. So we have some word data here, so I can create synonyms for the word composition. So all of that information, all of that data is built into the language itself. But then, if I take a look at the sentence, Sally and I went to the store yesterday, and I wrap it around in this function called text structure. You can actually, and I don't know if you can see that, you can actually see that it breaks it down into its actual structure. You can see that Sally is a proper noun, we've got a pronoun, noun phrase, and then all the way into the sentence. So again, this is in an English class or taking a look at grammar that you can actually decompose sentences now in the Wolfram language. Taking a look at science and nutrition, here I've made a Wolfram alpha call hitting the equal sign twice, and I just typed in the nutrition of 4 carrots. Again, everything that is included in Wolfram alpha you can get as a result in a Mathematica notebook or using the Wolfram language. So here it understands that I'm asking for the nutrition of 4 carrots, not just 1 carrot, but 4. And it does this very nice nutritional fact menu. I can get extra information. So it's a really nice tool for selecting those Wolfram alpha results. And then, of course, looking at math, just something that you've seen probably here and there and everywhere, is that we can just plot a variety of different expressions very easily. It's very readable to incorporate into your classroom. Moving into higher ed, let's take a look at some utilizing financial data. So what this code is talking about is, can you return the financial information or the stock data for GE since January 1st, 2013, and make a nice list plot, date list plot of them. So again, all the information, all that financial data is already built into the language, and it only took me, 2 functions to get that very rich data. We just had our talk on PDEs, but it's very powerful in the calculus and all the other mathematical courses. Another geography one that's one of my favorites is getting the geo-elevation data and then being able to plot that in a 3D manner. So here I'm looking at the 3D representation of Mount Everest. And then you could do all sorts of computations on that as well. One of the newer things to version 10 is the introduction of graphics of anatomical data. So here what it's returning, it should return, is a skull. There we go. Is a skull, and it includes all sorts of information about humans and anatomical structures. So that's available as well. Dynamic tools for students. Like I said, the demonstrations project is a huge resource. If you've never taken a look at it, it's a fantastic place to start. You can see how powerful the manipulate function is. And so this is something extremely basic, basically exploring slope-intercept form. So I'm plotting my function from -10 to 10. I'm manipulating both the slope and the y-intercept. I want to keep at the same. You can see slope changes, nice and smooth and interactive. I think this is one of the things that you can see with interactive courseware like the Pearson text, and we've got a variety of different textbooks and books that utilize the manipulate function, is that so often in STEM areas such as math, the information is static. And it's very hard for students to really understand and to make sense of, well, what happens if I change this piece over here? Or what happens if I change these parameters? And so by interacting with it dynamically, and with the Wolfram language, it's so easy to make those interfaces very easy. Here's another manipulate that I've got. So this basically is exploring the GDP. So I know it's a blob of code, but let's take a look at it. So basically, it's returning both the country, or it's looking for the country's GDP. It's going to be returned to us in US dollar, and then it's going to return both the country and the shape, and it should be from 2000, year 2000 till now. Okay, oh, a little small. Okay, so I've got a drop-down menu of the various countries in the top 10, or the group of 10, and then it generates the GDP as well as the country shape. Again, a nice little interactive piece of code, a nice GUI for your students to take a look at this data. Now my favorite. Actually get the students coding. It's one thing to be able to provide interactive content, but it's another thing for them to actually create it. So like I said, this is mostly for secondary students and non-computer science classes. I've worked with several middle schools and high schools to try and introduce computational thinking activities supported by Wolfram language programming. So this one is for a forensics unit, and what they were going to do is that they had this entomology piece of it. And so we worked with the teacher and said, what would be interesting is to automate the process of counting bugs in a picture. So what we did is we just started looking up functions related to image processing. We wanted it to be easy enough that the code didn't get exponentially huge, and that the students could walk through these steps and explore different values and parameters. So first thing, save my picture of bugs. And then this was another step that we had them do. We had them play around with different values to see what happened. So basically, binarizing the picture and then selecting the components. And this, it was a lot of work. I'm not an image processing professional, but the documentation is so powerful that I was able just to use the image processing guide to be able to look through the documentation and build this all on our own. So we selected the components. The students were playing around with values here and there. So we gave them the majority of the code, and like I said, they played around with the values. And then for the last step, we had them create this interactive piece to play around with, what is the optimal binarized value to count the most bugs in the picture. And then they submitted it through DataDrop. So again, something fun, something interesting. This is a way to automate a process that they normally wouldn't have thought of, like, oh, yes, I can use programming for my forensics unit. The next activity that I'm going to go through is for data analysis, either an intro computer class or a math class. What I had the students do was basically take a look at the various King Kong movies, their production budget, and then the revenue that they got from those. And I know that some of this might seem repetitive, and it's not the most optimal code to do it, but I really wanted the students to be able to realize, okay, this variable here contains the production budget and revenue for the 2005 King Kong. This one's the 1976 one. This is the 1933 one. And so what we did was we created a bar chart, and we used the movie posters, which is also in the Wolfram language, to generate, what was the budget versus revenue. Now that's not an accurate analysis of it because we have to account for inflation. What was the budget versus the revenue? And so I had them go through using inflation adjust and then quantity magnitude. Again, I realized that with functional programming you could probably do this all in one step, but I wanted them to see that this value here was for the 1976 film, this value here was for the 1933 film. And so then looking at the code again, you can really see that the difference between the budget and the revenue for the various King Kong movies, that the 1933 one had the biggest difference. Okay, next one, web development. And this is with version 10 and the advent of cloud deploying web forms, it has gotten so much more fun for my students to be able to create these crazy web forms that they just, oh my gosh, they just love it. So this is what they basically were working on, and I'll go back to my code here in a second, but this is the Ninja name generator. And so we've created a sequence of steps that walks the students through. They have to change pieces here and there, but eventually it gives them their Ninja name. So we create this Ninja name function. There are different ways to style it. They try it out. We talk about adding font color, font size, font family, and then they actually create their own web form. So again, we provide a lot of the code for them, but this introduces the code in a non-threatening way. The students feel successful, even though they haven't done a whole lot, but they get used to and they feel comfortable with the code. So this is what it looks like. Oh, I got signed in. Sorry, just a second. So let me pause here for a second. If you aren't familiar with form function and cloud deploy, so I've got this form function. We're taking in a string. We're going to name it a variable name. We're going to return a rasterized version of my new Ninja name. We're going to return it as an image. The appearance of the form, you'll see all these things here in a little bit. I've named my cloud object Ninja form, and I want to pause here and say that this is super important that you name your cloud objects, because if you go back and change things and you go back and change things and you haven't named it, you're going to end up with millions of unnamed cloud objects. So it's really important that you name your cloud object, because if I change something in my code, it'll just replace what I have here. And permissions are set to public, so anybody with this link can do it. So then I type in my name. Oh, it's not going to work with A's because they're blanks. But you get the idea. It generates their quote-unquote ninja name, and they have a blast. So I want to get into some administrative code. Because when I go out and do these activities and work with schools, there are certain things that we have to prepare ahead of time. So one of the things that I wanted to touch upon was using Wolfram's data drop. So we have this activity called 3D print your initials. And basically it goes through, you type in your initials, you style it the way that you want, and then you get a 3D version of your name, and then it exports it to a specific data bin. So that's the whole of the activity. Well, obviously, in order to, and then we go and print out the names. We go and 3D print out the names. So for us, working in a cloud environment, we needed a way to export the 3D files, the 3D names, collect them so that on our own time we could 3D print them out. So we use Wolfram Data Drop, and I'll go through the code here in my presentation. So the very first thing that we needed to do was to actually create a data bin. So the function is called create data bin. I named it my bin for STL files because I want to be able to keep track of these bins, and I wanted the permissions to public because there are going to be quite a few people accessing these files. So I wanted to make sure that everybody could just access them. So if I click on this plus sign, you'll notice that I've got some extra information here. And what you're looking for is this short ID. So I'll just go ahead and copy that. And then to have our students submit the files, we added this code, and you saw it in the activity, but obviously instead of XXX, we need to specify the actual data bin that we're using to collect this stuff. So what's happening in my 3D printed activity is that it's adding to my data bin the name of the student, so the student would have to type in their name. So we knew whose was whose. You know, I need to know that, okay, this one is Sally's. And then it also added a link. It added a link to their STL file, and permission set to public so that we, their teachers, could take a look at it and download it. The next thing that we found super helpful is to create a schedule. So this is our way of easily getting cloud activities to the students. Going through these various steps, it'll eventually look like this. So you're looking at one of the actual schedules that we use for working with one of our schools. So you can see in week 1, these are the various cloud activities that they'll be working on. And these are all links to notebooks, to cloud notebooks. So what you're going to do is create your local schedule notebook. So this thing, I have a local copy of it. And then to populate it with the activities, so obviously you want to connect to the cloud. So I should already be connected, yep. And then what I'm going to do is bring in, so this is the activity file. So I'm going to bring in the activity, export the activity as a notebook, deploy it, make sure that I'm naming my file, naming my activity getting started, and this should really just be permission set to public. And I deleted something. No. There we go. Oh, oops. Wrong computer. Anyways, so you'd export your Getting Started notebook, and then now you've got this link. Well, what happens here with the www is that it actually goes to a notebook that's basically its own web page, so it looks something like that. Well, for our students, we wanted them to be immersed in the actual programming environment, so I added some extra code here. Instead of the www, I wanted it to replace with develop and then create a hyperlink, and so this will actually take us to oops. This will actually take them to that object. And then you just add the activity link to your schedule and then deploy the schedule to the cloud. So for closing, I just wanted to mention a couple of resources to get you started working on your own. Obviously, we have the Wolfram community. It's an excellent resource for sharing and asking questions. Dr. Stephen Wolfram just came out with an elementary introduction to the Wolfram language. So if you yourself, or if you have students that are interested in just getting sort of a basics 101 on how to use the Wolfram language, this is an excellent resource. It's online right now that you can get access to it. It really goes through and takes you one step at a time, looking at various functions and how to really think about functional programming with the Wolfram language. And then, can't stress it enough, everybody knows it, the documentation is an amazing resource, especially for the new functionality in version 10 and then 10.3. Everything's there, has examples. So for my talk, I was really focused on getting students programming. I really like that approach. It really engages the students to be able to see, oh, look, I created something. Oh, look, I was able to do this thing that I wasn't able to do before. I did want to mention that in December, we'll have another educational workshop. It'll be about 45-50 minutes. It's called Programming for Computational Thinking, and we'll be going over more of these types of activities that you can bring into a wide variety of classrooms. I did want to mention that we are constantly looking for secondary school teachers that are interested in bringing in Wolfram language to your school. So if you already have a Mathematica site license at an elementary or secondary school, that's great. But if you or you know somebody that might be interested, please give them my information, because we're really trying to work with teachers to develop these mini Wolfram language units.